Today we're going to solve some integration problems using u substitution. So our first problem is take the integral of 3x squared plus 2 times e raised to the power of x cubed plus 2x dx. So first we have to find u. When finding u, we take the derivative of u right after. So pick a u that the derivative will help cancel out the remaining stuff. So we're going to pick x cubed plus 2x for our u. So the derivative of that du equals 3x squared plus 2 dx. Don't forget the dx because it's important. So now we're going to get dx by itself. So dx equals du divided by 3x squared plus 2. Now we're going to sub all these back in. We're going to swap out our u and swap out our dx for our new one. So integral of 3x squared plus 2 times e raised to the power of u du divided by 3x squared plus 2. So now our 3x squared plus 2's will cancel out, leaving us with the integral of e to the u du. So now we're going to integrate. The antiderivative of e to the u is e to the power of u. So e raised to the power of u plus c. Now we're going to swap everything back in. So our final answer is going to be e raised to the power of x cubed plus 2x plus c. Next, we're going to find the integral of x divided by x squared plus 1 dx. So to pick our u, we're going to pick x squared plus 1 because x squared, the derivative of that is 2x. So 2x dx. Now our dx is going to equal du divided by 2x. So now we'll swap in our u and our dx. So we have integral of x over u du over 2x. So now our x's are going to cancel, and our 2 is going to move out to the front. So we have 1 over 2, because this is on the bottom, times the integral of 1 over u du. Now we're going to integrate. So the antiderivative of 1 over u is the natural log of u plus c. So our final answer is natural log of u over 2 plus c. Now we're going to find the integral of sine 5x dx. So for our u, we're going to pick 5x, and the derivative of 5x is 5 dx. So dx is du divided by 5. So now we'll sub in our u and our dx. And the integral of sine u du over 5. So we're going to move our 1/5 out front. So 1 over 5 times the integral of sine u du. Now we'll integrate. So the antiderivative of sine is negative cosine. So we have 1 over 5 negative cosine u plus c. So one last step, we've got negative cosine 5x over 5 plus c. And there's our final answer. Now we're going to find the integral of x cosine x squared dx. So for our u, we're going to pick x squared. The derivative of x squared is 2x dx. So dx is going to equal du divided by 2x. Now we'll sub in our x and dx, or our u and dx. So we have the integral of x cosine u du over 2x. So here our x's are going to cancel. We're going to move our 2 out front, or 1/2 out front. So we have 1/2 the integral of cosine u du. Now we're going to integrate. The antiderivative of cosine is sine, so we have 1/2 sine u plus c. Now we'll sub in our sine, or our u. We have sine x squared over 2 plus c. And that's our final answer. Now we're going to find the integral of e raised to the power of 3x divided by 1 plus e raised to the power of 3x dx. So for our u, we're going to choose 1 plus e 3x. So the derivative of that is going to be 3e 3x dx. So we'll get dx by itself. We've got du divided by 3e raised to the power of 3x. So now we'll sub everything in. We have the integral of e 3 raised to the power of 3x over u du over 3e 3x. So our e raised to the power of 3x is going to cancel out, and we're going to move our 1/3 out front. So we have 1 over 3. There's the integral of 1 over u du. So the antiderivative of 1 over u is 1/3 the natural log of u plus c. So our last step is going to be the natural log of u, or a natural log of our u. So 1 plus e raised to the power of 3x over 3 plus c. There's our final answer. So now we're going to find the integral of x times the square root of x squared plus 4. So for our u, we're going to pick x squared plus 4. We'll take the derivative of that. We have 2x dx. And to get dx by itself, we have du divided by 2x. We'll sub everything back in. We have the integral of x times the square root of u du divided by 2x. So our x's are going to cancel. We'll move our 1/2 back out front. So we have 1/2 times the integral square root of u du. So we'll rewrite this as 1/2 integral of u 1/2 du. So now we're going to integrate. We have 1/2 times 2 over 3 u raised to the power of 3 over 2 plus c. So you're going to equal 1/3. We'll sub back in x squared plus 4 times 3, or raised to the power of 3 over 2 plus c. And there's our final answer. So now we'll take the integral of x divided by square root of x squared plus 9 dx. So for our u, we're going to choose x squared plus 9. Take the derivative of that. We have 2x dx. To get dx by itself, we have du divided by 2x. Now we'll sub these back in. We have the integral of x over square root of u du over 2x. So now our x's are going to cancel, and we'll move our 2 back out front. So we have 1/2 the integral of 1 over square root of u du. So we'll rewrite that as 1/2 square root of u raised to the power of negative 1/2 du. So now we're going to integrate. We have 1/2 times 2 over 1 u raised to the power of 1/2 plus c. So now these are going to cancel out, leaving us with u raised to the power of 1 over 2 plus c. Now we'll sub back in, so we have x squared plus 9 raised to the power of 1/2 plus c. Rewrite this one more time. We have the square root of x squared plus 9 plus c. And that is our final answer. So now we're going to take the integral of dx divided by x ln x. So our u, we're going to choose the natural log of x. Our du is going to be dx over x. And our dx by itself is going to be dux. So now we'll sub everything back in. We have the integral of dux over xu. So now these two x's are going to cancel out. We have the integral of du over u. So now we're going to integrate. We have the natural log of u plus c. So we'll sub in our u again. So we have natural log of the natural log plus c. And there's our final answer. If you like this video, hit the like button. If you want to see more, hit the subscribe button. And if you need a little bit of help with your math class, check out my Circle community, link in the description below.